Imagine looking up at the night sky and pondering the vastness of space. Now, picture a single planet surrounded by 83 moons, more than any other planet in our solar system. But here's the kicker. Just a few decades ago, we thought Saturn had only 18. So, what changed? How did astronomers uncover this cosmic treasure trove of moons? And why is Saturn such a moon magnet? Saturn's moons aren't just numerous, they're mysterious, each with a story waiting to be told. From Titan, with its thick orange haze, to Enceladus, a frozen moon spewing geysers of water into space, every single one challenges our understanding of how celestial bodies form and evolve. Together, these moons create a celestial system that is as breathtaking as it is baffling. But how did we go from knowing about 18 moons in the 1980s to a staggering 83 today? The answer lies in technological breakthroughs. Modern telescopes, armed with powerful lenses and advanced imaging software, have unveiled moons that were previously invisible to us, some as small as a few kilometers across. These faint, irregular satellites, which orbit Saturn at incredible distances, were hiding in plain sight, waiting for humanity to find them. And it's not just their number that amazes us, it's their behavior. Some of Saturn's moons, like Hyperion, spin chaotically, defying predictable patterns, while others have orbits so tilted or eccentric that they seem out of place. Then there are moons like Pan and Atlas, shaped like flying saucers, which almost feel like a cosmic joke. What's more, Saturn's majestic rings might play a crucial role in the formation and destruction of these moons, adding another layer of complexity to the mystery. Can you imagine the secrets that a single planet and its 83 moons could hold? Why does Saturn, of all planets, host such a remarkable collection of satellites? Could these moons, each unique in its own right, help us uncover the story of how the solar system evolved? One thing is certain, Saturn's moon system is not just a scientific curiosity. It's a gateway to understanding the very nature of our cosmic neighborhood. But how did these moons come to exist in the first place? To answer that, we need to delve into the fascinating theories behind their formation. Saturn's moons are more than just celestial ornaments. They are worlds unto themselves, each with its own story and secrets. Among the 83, a few stand out as titans of the sky, commanding the fascination of astronomers and dreamers alike. Titan, the largest, looms as a planet-like giant, wrapped in a dense orange haze that shields a landscape eerily similar to Earth's. Then, there's Enceladus, smaller, yet no less extraordinary, a frozen globe that shoots geysers of water into the void. These two moons, along with others like Mimas and Hyperion, form a cast of cosmic characters that might just redefine what we know about life in the universe. Let's start with Titan, Saturn's largest moon and the second largest in the solar system. Titan is unique. Its thick, nitrogen-rich atmosphere is unlike anything else found on moons. This atmosphere is so dense that it allows weather systems to form, complete with rain, rivers, and lakes. But don't pack your swimsuit just yet. Titan's lakes are filled with liquid methane and ethane, hydrocarbons that would be deadly to humans. Still, the similarities to Earth are striking. Could Titan's chemistry offer a glimpse into how life might arise in extreme environments? Scientists think so, and missions like NASA's upcoming Dragonfly drone are poised to unlock more of Titan's secrets. And then there's Enceladus, a moon much smaller than Titan, but no less intriguing. Beneath its icy crust lies a vast ocean of liquid water, an essential ingredient for life. What makes Enceladus truly remarkable are the towering plumes of water vapor, salt, and organic compounds that erupt from its south pole. shooting into space like cosmic geysers. These plumes suggest not only the presence of water, but also the possibility of hydrothermal vents at the ocean floor, a potential cradle for alien life. Could microbial organisms be thriving in this hidden ocean? It's a tantalizing question, and one that continues to drive exploration. But Titan and Enceladus aren't the only stars of the show. Mimas, the so-called Death Star moon, grabs attention with its enormous Herschel crater, giving it an uncanny resemblance to the iconic weapon from Star Wars. Meanwhile, Hyperion spins chaotically, like a tumbling sponge, and Iapetus boasts a stark duality, one side jet black, the other icy white. Each of these moons defies expectations, adding more layers to Saturn's celestial enigma. Could these moons be the key to finding life beyond Earth? With Titan's complex chemistry and Enceladus's hidden ocean, the possibilities are endless. They remind us that the search for life is not limited to planets. It extends to the frozen and fiery corners of our solar system. But these discoveries beg a deeper question. How did such diverse and fascinating moons come to orbit Saturn in the first place? Let's unravel the theories behind their origins. The story of Saturn's moons begins billions of years ago, in the chaotic early days of the solar system, a time when the cosmos resembled a construction site, with gravity playing the role of a giant crane. Dust, gas, and rocky debris swirled chaotically around the young sun, colliding and coalescing to form planets and moons. Somewhere in this cosmic frenzy, Saturn began to emerge, pulling material into its orbit and laying the foundation for its magnificent lunar family. But how exactly did Saturn end up with 83 moons? The answer is a billion-year-old puzzle with several intriguing pieces. One leading theory suggests that many of Saturn's moons are leftovers from the planet's formation. As Saturn grew, its immense gravity created a disk of gas and debris around it, much like the Sun's protoplanetary disk. Within this disk, smaller clumps of material began to stick together, eventually forming moons. Titan, the giant of the group, likely emerged from this process, growing large enough to hold onto its thick atmosphere. But not all moons formed this way. Some, like Enceladus, may have formed later from icy material ejected by collisions or even from Saturn's own rings. Speaking of collisions, the early solar system was a violent place. Moons and planetesimals frequently smashed into one another, breaking apart and reforming in new configurations. It's possible that some of Saturn's moons are the shattered remnants of larger moons that didn't survive the chaos. For instance, the irregular shapes and tilted orbits of outer moons like Phoebe suggest a history of catastrophic impacts. Imagine the solar system as a cosmic demolition derby, where destruction sometimes leads to creation. But not all of Saturn's moons were born there. Some might be captured wanderers, asteroids or comets that strayed too close to Saturn's gravitational pull. Phoebe, with its distant retrograde orbit and dark carbon-rich surface, is a prime example. Scientists believe it may have originated in the Kuiper Belt, a region of icy bodies beyond Neptune, before being ensnared by Saturn's gravity billions of years ago. The same gravitational forces that allowed Saturn to collect these moons may also have prevented them from escaping, turning the planet into a cosmic collector. It's not just individual moons that tell the story of Saturn's formation, it's their diversity. From Titan's thick atmosphere to Hyperion's sponge-like surface, these moons are a mosaic of different origins and processes. They are clues to the solar system's turbulent past, each one a time capsule from a different era. What if Saturn's moons are more than just satellites? What if they're pieces of a cosmic puzzle? revealing how gravity, collisions, and time work together to shape not just Saturn, but the entire solar system. By studying these moons, scientists hope to uncover secrets that could help us understand how planets and moons form across the universe. But the mysteries don't stop here. As we unravel their origins, we also find hints about their possible futures and their connections to Saturn's iconic rings. Among Saturn's diverse collection of moons, some stand out not just for their appearance, but for their outright defiance of what we consider normal behavior. These are the icy oddities, the moons that spin chaotically, display stark contrasts, or seem to ignore the cosmic rules we thought we understood. They're more than curiosities. They're windows into the hidden forces shaping our universe. So, what makes these moons so peculiar? And could their quirks reveal secrets we've yet to uncover? Take Hyperion, for example, a moon that looks more like a sponge than a solid rock. With its porous surface, covered in craters that make it seem hollow, Hyperion is already visually strange, but its behavior is even more baffling. Unlike most moons, which rotate predictably, Hyperion tumbles erratically through space, as if it's caught in a cosmic pinball machine. Scientists believe this chaotic motion is due to its irregular shape and weak gravitational interactions with nearby Titan. It's as if Hyperion is caught in a gravitational tug-of-war, with no clear winner. And then there's Iapetus, Saturn's yin-yang moon. One hemisphere is bright and icy, reflecting sunlight like a mirror, while the other is as dark as coal, absorbing nearly all the light that hits it. This stark two-tone appearance has puzzled astronomers for centuries. The leading theory suggests that Iapetus's dark side is covered in material from Phoebe, one of Saturn's outer moons. As Phoebe's dusty debris falls inward, it coats Iapetus, creating its distinct split personality. But even this explanation raises questions. Why has the material settled so perfectly, dividing the moon into two contrasting halves? Saturn's gravity plays a starring role in these peculiarities. The planet's immense gravitational pull doesn't just keep its moons in orbit, it actively shapes their behaviors. For moons like Hyperion, Saturn's gravity creates resonances with other moons, pushing them into unpredictable motions. For Iapetus, Saturn's pull might influence its slow rotation, which allows one side to gather more material over billions of years. Gravity here is not just a force, it's an artist, sculpting the moons into strange and beautiful forms. And the oddities don't stop there. Pan, one of Saturn's smaller moons, is shaped like a flying saucer, with a prominent ridge around its equator. Atlas, another small moon, shares this bizarre shape. These saucer moons likely owe their form to material accumulating along their equators, a result of Saturn's rings and gravitational forces. It's as if Saturn's moons are participating in a cosmic game of dress-up, each wearing a unique and unexpected costume.